applications of Biot Savart Law. The magnetic field at any point on a straight wire is always zero. How and why we will see. This is the Biot Savart Law in the vector form, it is in the magnitude form. Suppose P, this is the long straight conductor and the point P is lying here. This is point X side and this is point Y side of the conductor. What is dl vector? Suppose we take a dl vector, a small element length. dl is equal to element length, and this will produce because current is flowing in the conductor, this will produce magnetic field at every point. Now we are interested to find out at a point P on the wire. So the distance between current element dl is equal to r is equal to distance between point P and the wire, that is r. We can say in vector form, we can say like this, we can write like this. And dl is also a vector. Why? That current is flowing in this direction, we say dl vector. The direction is simply, we need not worry, along the current direction. That is, current is flowing this way, it means dl vector is in this direction. dl. So what is the angle between this vector and this vector, r vector and dl vector? Theta is equal to 0, because both are heading in the same direction. We can use this formula also, This formula gives in vector form. What is the dl cross r? See, dl cross r magnitude is equal to dl r into sine angle between the dl and r vector. Since sine theta is equal to 0, dl r into sine of 0 is equal to 0 that is db. This, once this portion is 0, this vector form itself also becomes 0, and sine theta is equal to 0, it means db is equal to 0. That is the magnetic field produced by this elemental length at the point P, which is lying on the conductor, is equal to 0. This we can do it by using another formula also, that is other form of the Biot law. This is derived from this formula. Let us see how that, with that also how we prove it. See, if the point P, we take a general point P. This is the perpendicular distance. We call it as E, and this is the point Q, and this is dl. This portion is dl, and the distance is r. Never get confused. Joining one's end, that is x end, and joining y end. This is y end of the long conductor. This is the reference line for theta, and this is the angle phi 2. We are measuring from this reference this way. In the which direction? It is in the clockwise direction, which we assume it positive, above the line positive. In this one, we measure as phi 1. This is anti-clockwise direction. This is we measure as negative angle. This is positive angle, negative angle. It means we have to remember thing, from this reference line, we go in clockwise direction for theta 2. Some books it may be theta 1, this may be theta 2, but we are not worried. This angle is always positive and this angle is negative. That's all. This may be theta 1, this is theta 2. No worry. And the formula we have derived for B is equal to mu naught by 4 pi, and substituting all the value on Biot Savart formula I divided by A into sine of phi 1 plus sine of phi 2. This is the formula we have derived from Biot Savart formula. We made the derivation in the previous video. Now what is theta? See, if the point is lying on the, this is the point P, the point is lying on the wire. It means point P is shifted here. So from P, we have to draw a line to the X end, and that is your phi 1. From P we go anti-clockwise direction, that is here downward. Phi 1 is equal to 90 degree. Downwards, if you take it, you can say take it as a minus 90 degree, and from here we go anti-clockwise up to the line joining P and Q. This is, what is this angle? This angle is, this is also, this is this angle. What is this angle? 90 degree. This is 90 degree, and this is also 0 degree. Sorry, both are 0 degree because the point is also here, the end is also the angle. See, if it is, then we can say phi 1. If it is same line, then is equal to 0 degree. This is also, this is like, it will come like this on the same point. It is, if it is like this, then we can write R like this, we can write the angle, but it is going, this is also phi 2 is equal to 0, and phi 1 is also 0. Putting in this formula, the net magnetic field is equal to mu naught by 4 pi into I by A, where A, remember this is R. R is the distance from the DL elemental length up to the point P, and A is the perpendicular distance. A into sine of 0 degree plus sine of 0 degree. It means sine of 0, both are 0. It means magnetic field, where B means magnetic field produced due to the entire length. dB means magnetic field produced by this elemental length B. So it means we can come to the conclusion that magnetic field due to a straight wire at any point along its length, it means it is lying on the point P lies on the conductor. The magnetic field produced by this one, or the entire current flowing through this conductor, is equal to 0. Here you have to remember one thing, that this line is the reference line. If you go, this is here going in the anti-clockwise direction, we measure it as a positive negative value. If you go from here to here and clockwise direction, it is measured as positive. No hard and fast rule, this should be negative and this should be positive, we assume. If it is negative, this will be positive, simple, nothing else. If the point P, at which we are interested to find out magnetic field due to current flowing in the conductor. This is I flowing. Earlier this was the point P. Now the point P is come near, this is infinite length. We have taken the portion of the length, this is a dl vector. Okay, and now you see phi 1, we see the magnetic field produced by the infinite length conductor is equal to mu naught by 4 pi into current flowing through this one, and the perpendicular distance from the point P to Q, this is Q, and sine of phi 1 plus sine of phi 2, this already we have seen it, and this is conducting. See, this is point, this is perpendicular, it has come near here, this point has come near here, and this is the point. And this is the line joining with X and Y, and now this is the line joining X and Y. What is this angle? The angle will be, if we enlarge this is P, this is X end, and theta is equal to 0 degree. That is theta 1 is equal to 0 degree, because the reference line has come here, and this same angle, what is the angle between? We see, we have to remember from P, we join this point, join the point P up to the one end, bottommost end, and we measure with respect to this line, we measure the angle phi 1. But now it has come here, and we join this point P and this X side, and this is the reference line, and this also, and this is XP, and this is P and Q. When it is P is here, P is here, this point will be somewhere here, then this is, we call it as phi 1. Now P has come here. So this is the same angle. What is the difference? What is the angle between this one and this one, which is equal to phi 1 is equal to 0. What about the phi 2? Phi 2 is equal to 90 degree. How? Since, because see, when the length is increasing, with reference we measure this angle. When it is increasing, it will keep moving, and since it has come here and keep moving, it means the angle between this and this, and we join this y side has gone infinite length, so this will be almost 90 degree. It means it is almost 90 degree. This is point P and this is y, because when it is increasing, this angle phi 2 will also increase, keep increasing, and since it is infinite length, it will keep moving up to, so this angle will become 90 degree. In this case, the magnetic field is equal to mu naught by 4 pi into I divided by perpendicular distance into sine of 0 plus sine of 90 degree. As sine of 90 degree is equal to 1, this is equal to 0. So B is equal to mu naught by 4 pi A into I. This is the expression for if the conductor is the point at this point, close to this point is P is here, very close, and this is infinite length. In that case only, the magnetic field produced by the entire infinite length conductor at point P, which is lying closer to the one end, if it is lying closer to this point, obviously this will become 90, this will become 0, and this will become 90, this will become, result is same, and magnetic field direction we can find out using right hand thumb rule or right hand palm rule. So this is another case. If it is lying, so here only the confusion comes how this become 90 degrees. As this angle, this length is increasing, it keep this angle, joining angle, it will keep, once it is moving, it will become 90 degrees. Now when it is coming closer, we join this point and this point is very closer, then we join like this, the angle with reference to, this is the reference level, with reference to is 0. It means a point is closer to one end, that angle of phi will become 0, and another angle, that is phi 2, one angle will become 0, another angle will become 90.